Hi guys, I'm just going to talk you through the solutions to the algebraic fractions assignment that was on over the holidays. So just one at a time. So for this first one, I've just broken it down. 5 times x is what the top line is, and 10 I've just broken down to 5 times 2. Because I've got a common factor of 5 top and bottom, I then just cancel them out and I end up with x over 2. You could of course have seen that from the beginning, that 5 over 10 is the same as 1 over 2, and then you just bring the x down as well. So you could have gone straight to the answer for that one. Second one, again, I've just broken it down for you. So 12 comes from 12 times, you get your x squared, x times x, and your 36 comes from 12 times 3 times x. So I've then just cancelled the 12 top and bottom, and I've cancelled one of the x's top and bottom. So overall, I'm left with x and a 3, which is my final answer. Again, you could have jumped straight to that if you'd noticed that 12 and 36 is just a third, and x squared over x. Well, you get a cancelled x on the top, and one of the x's cancelled on the cancelled x on the bottom, and one x cancels on the top as well. Okay. Second one here, really I'm just highlighting to you that we've always got a times by 1 on the top, so we're never left with 0 on the top. But because we've got something on the bottom here, times them by something else, but that same thing appears on the top, you can then just cancel them and you end up with 1 over whatever you've got left, which is just that. Okay. B, much trickier one really. You've got to factorise the top and factorise the bottom, and then once you factorise both of them, you then cancel. So it's a wee bit of practice of factorising, which would be valuable for you anyway. And then because you've got the same thing top and bottom, you can cancel the x plus 2, and then don't forget to rewrite your answer just with what you're left with. Okay, question 3, trickier. Adding fractions this time. The key thing to remember is whether it's algebraic or numerical, when you add two fractions, they've got to have the same denominator. So basically I take this first fraction and I times it by the denominator of the second fraction, top and bottom. Now remember, that's really just equivalent to timesing by 1. That there is just worth 1. So you don't actually change the value of it, you just change what it looks like to create an equivalent fraction. So you end up with 4 times m. It's 4m, 4 times 5, and I've made it into one fraction now, because when I do the same thing over here, 5 times m is 5m, and 4 times 5 is also 20. So they've got the same denominator, so I can make them into a single fraction. Now we can add the numerators, so 4m plus 5m just gives you 9m, and that brings it together to your final answer. B, similar. Getting a wee bit trickier though, so I'm basically taking the whole of this fraction and timesing it top and bottom by the denominator of the other fraction. So you can see I put 5 over 5, taking this whole fraction and times it top and bottom by 2 over 2, your denominator of your first fraction. So I've actually then written that out in a bit more detail. I've taken all of this and timesed it by 5, and I've taken all of this and timesed it by 2, and then on the bottom 2 times 5 is going to give me 10. So I've made it into one single fraction. Then I multiply out the brackets. So 5m plus 20, and then 2m, take away 6. What's your sign there? And then collect your like terms together. 5m plus 2m is 7m, and then 20 take away 6 is going to give you 14, and you've still got the 10 in the bottom. Right, I've done this one. I nearly missed it. I didn't realise there was a part C there until at the end. So this one, trickier, much trickier really. So I've taken the whole of this fraction, now there it really is there, and I've timesed it top and bottom by the denominator of the other fraction. So you can see x plus 1 appearing times by this, and x plus 1 appearing times by this. I've then done the same to the second fraction. I've taken x minus 2 over x, there they are, there and there, and I've times them top and bottom by the denominator of the first fraction. So you can see there and there the x plus 2 appearing. I've then multiplied out the double brackets in each case on the top. So I'm going to get an x squared plus x plus 1, there it is there. And then on this bit here I've got x squared plus 2x minus 2x minus 4. So there it is appearing there. And then on the bottom I've got the same denominator, so I just leave that as it is, and then I've just collected all the like terms together. So I've got an x squared plus an x squared, so I've got 2x squared. I've got x plus x minus 2x plus 2x, which just leaves me with 2x, and I've got 1 take away 4 there, which leaves me with minus 3. Okay. Right, question 4 then, multiplying fractions. Really, I've simplified before I go to multiply, so I spotted that 21 and 7 both divide by 7. So divided that by 7, divided that by 7, and then I divide that by 3 and divide that by 3. So I'm left with 3 there, and then a k and a k cancel. So on the top, all I'm left with is 1 times 3, and on the bottom, all I'm left with is 1 times 3. So I end up with 3 over 3, which just simplifies down to 1. The second one, so this time again, I've spotted that 3 and 9 both divide by 3, so I end up left up with 1 and 3 there. 5 and 2 don't simplify, so I've got an x and an x squared, so I get rid of the x here and I get rid of one of the x's here, so I'm left with 1 times 2 is 2, 5 times 3 is 15, and I've also got an x left there. Okay. When we're dividing fractions, our rule is that we change the sign to multiply and we flip the second fraction upside down, which is what I've done first of all. So I end up with a over 2 instead of 2 over a. First fraction remains as it is. Now that I've got a multiply, I just do the same again here and just simplify. So you can see I've got an a here that I've cancelled, and I've cancelled one of the a's here. So I'm left with 1 here, and I've still got an a times 2, which I'll write as 2a. Final question, same kind of thing. Again, change the sign to multiply, flip this fraction upside down, so I end up with a 3y on the top and the 4x squared on the bottom, and then again just looking for simplification. So I've got a 2 here and a 4 here, so they both divide by 2. I've got an x and an x squared, so if I cancel out an x on the top and cancel out one of those x's there, so I've still got that one left. I've also got a 3 here, which can't be simplified, and on the top I've got a y, and on the bottom I've got a y, so I just cancel those. So all I've got left with is 1 times 3, which is 3, and on the bottom I've still got a 2 from here, and I've still got an x, and my final answer then is 3 over 2x.